All right, so welcome everyone. My name is Troy Marshall. I'm the Director of Application Security and Reliability for Ellucian. And I'm here to talk to you today about DevSecOps and bringing law and order to your CICD pipeline. This is not a theoretical talk, this is real. This is something we've built. This is something that's in operation. It's something we use every minute of every day. All right, so what are we going to talk about today? First, give you a little bit of background. You kind of need to understand Ellucian as a company to understand our evolution to DevOps and DevSecOps. So in the movie RoboCop, he was given 3 primary directives, right? Serve the public trust, protect the innocent, and uphold the law. And we built our own RoboCop using technology, automation, combined with the humans within our application security team in order to bring law and order to our DevOps practices. And so I'm going to talk to you today about how our very small AppSec team has scaled our security program to cover more than 70 Scrum teams within our organization. So a little bit about Ellucian. We're not a startup. We've got a 40-year history in higher education technology. So we've been developing ERP systems. Anybody from VCU use Banner, right? Anybody know Banner? Yeah, that's us, okay? So that's one of our many products. So we've got some very mature existing technology. We're also building a lot of greenfield projects. So it's a very diverse group of teams and products that we work with. So Ellucian as a company, we have 2,400 institutions in 40 countries that serve 18 million students every day using our software. So the Ellucian Ethos platform was purpose-built for higher education. And you see the 4 pillars on the right. It's integrated. It's extensible. Built-in analytics, and most importantly, it's secure. We have a commitment from the highest levels in the company, from the board of directors down, to ensure that our products are secure. That is our mandate. Everyone in the company owns security, and they know it. This isn't something that one small team's responsible for. It's a culture of ownership. So RoboCop, anybody remember this movie? 1987, right? Peter Weller. Okay, so he's a loving husband, father, cop, gunned down by Boddicker, real nasty guy, and brought back by the mega corp, right, Omnicorp, as this cyborg police officer, right? What was the tagline? Part man, part machine, all cop, right? The future of law enforcement. So we're going to talk about RoboCop, our DevSecOps framework. Right? Same thing. Part man, part machine, the future of application security. So the prime directives, we talked about these. Serve the public trust, protect the innocent, uphold the law. So what does this mean for security, in particular application security? So how do we define the public trust? So it's trust created for the promotion of public welfare and not for the benefit of one or more individuals. So what does this mean in the context of application security? It means be a business enabler, right? We want to create business-driven security versus rubber stamp, right? This is about open collaboration throughout the organization. Everybody loves the buzzwords leaning in versus saying no, right? This is not security saying no, 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 right? Any of you heard Jason Ross talking earlier? That won't work, right? We've got to lean in. We've got to become partners with our development and our operations organizations if we're going to be successful in DevOps. Right? Protecting the innocent. So yes, we have 18 million students that use our software, but we also have our poor innocent developers. And so we want to make sure that we are there to protect them as well. So Most application security teams are very small. And so we can't do it on our own. We have to be able to scale security through the use of security champions, through the use of satellites within the organization. And with DevSecOps, we're able to scale that through the use of technology and automation. You know, developers, they're under pressure. You know, the business wants features, they want releases, and they don't want them tomorrow, they want them right now. And so we're there to help them ensure that the product they are developing in that fast-paced environment is as secure as possible. Right? And developers are lazy, not in the bad sense, right? In the good sense that they don't recreate the wheel. They find libraries and they reuse technology, but it's important that as open source technology proliferates throughout your products, whether through the use of Java libraries or Node, you're able to make sure that those underlying components are also secure. So we're going to talk about how to handle that as well. And then upholding the law. So to uphold the law, you have to know what the law is. So this assumes you start from a place of established policy, and then you use DevSecOps to enforce that policy through automation. Do you enforce cryptographic standards? How about input validations? Do you have security gates? How many people here have security gates for releases of applications? No, not many. Okay, we do. We have a number of them, and all of those are automated within our pipeline. So, if you guys attended Jason Ross's talk earlier, he got into a little bit of what DevOps is, but it really means different things to different organizations. So for us, we define it pretty simply, and it's a cultural aspiration. Not tools, it's not a framework, it's not technology, it's a cultural aspiration, right? Where development, ops, security architects, QA, the business, everyone is working together with very minimal barriers in order to advocate for security, right? And advocate for speed, advocate for the customer. Right? So our mission statement, automate all the things. And so we make sure that we don't forget tasks. We use automation. How many people here use checklists, right? Repeatable process. Everybody loves a checklist. In the operating room, doctors have a checklist to make sure they don't leave a tool inside your abdomen when they're doing surgery. Well, those are perfect. Any repeatable tasks like that, you could probably automate. It's a great opportunity to take the human element out of it, to take those checklists and now automate those checklists. Your tasks now are not only repeatable, but they're scalable, where one person could take a checklist and go through and review code before an application's released. You could have 1,000 virtual machines do it concurrently. So the scaling is key to DevOps. And then this allows us to focus on more high-value efforts. Things in security, for example, like threat modeling, manual penetration testing, the things that the machines can't do right now. So when we first started moving towards DevOps, and they came to my team and said, we need you to integrate security into DevOps. This was us. We're, whoosh, let's go. We're ready, guns blazing. So we learned pretty quickly, though, that the way that we used to do things just flat wouldn't scale. We failed. We tried, we failed. We learned a lot of lessons. We regrouped, we picked things back up, and we developed a plan that is now working very, very well for us. So, Sec DevOps, DevSecOps, DevOpsSec, rugged DevOps. You guys have heard all those, right? So we've settled on DevSecOps. It's pretty simple. I did a Twitter poll. My followers said it's DevSecOps, so that's what we're calling it internally. So this is about, again, culture, automation, measurement, and sharing. Right? And so the way that RoboCop came about. If you look at the way DevSecOps is spelled, this is so corny. One of my guys said, haha, DevSecOps, we put the cops in DevOps. Oh. Literally, yeah, it's stuck. So that's how we came to lovingly refer to our framework as RoboCop. So we've integrated a lot of different technologies into our DevOps pipeline. And just like any job, it's important to pick the right tools. So we decided early on that we were going to integrate certain technologies, and then we would grow from there. So it's important that you use the right tools, right? You're not going to hang a picture with a sledgehammer, okay? So it's important that you select the right tools for the job when it comes to DevOps, right? So we've decided we've integrated our static application security testing. This is really looking at the application source code along with those dependencies to identify vulnerabilities very far to the left in the life cycle. We've got dynamic security testing where we're looking at the applications in their running state further along in the life cycle. We've got infrastructure testing, security testing, where we're looking at the underlying operating system. We're looking at the application servers to ensure that we're patched, we've got proper configurations, that sort of thing. No single automated analysis technique is going to find every vulnerability. And so this isn't a cure-all. Implementing DevSecOps doesn't mean you can fire all your security people. It just means that they now have more time to go do value-add activities rather than spending time, running help tickets and kicking off manual scans and waiting for results and doing analysis. Right. So our static application security testing. With this, we want to inspect the flow of code as it's coming in to our repository. Right? So we are on every check-in. We're looking at source code. Our developers within their IDE can examine their source code for vulnerabilities before it's even checked in. And we can run this really early in the life cycle. Unlike the dynamic tools which require a running application, you can use static analysis from the very first line of code, which is important. All right? Jason talked earlier in his SecDevOps presentation on how development wishes security could get involved earlier. Well, now we can get involved from the very first line of code. Right? Not only that, but we can check those underlying libraries, your struts and other libraries to ensure that those are secure as well. And also, another thing that we use is pre-commit hooks. We talked about that, right? Making sure that, for example, you don't have your Amazon secrets in a configuration file checked into a public Git repo. That's very bad. All right, so our dynamic application security testing. This is really in looking at the application in its running state. So with this, we can find things that you can't identify via static application security testing. We can find implementation issues. Are you using weak crypto on your web server? Are you using weak TLS? We can find those things as the application's running. So the challenge with this, though, is to find all the paths through the application and to the content. So for example, single page applications written in Angular. It's very, very difficult to crawl those applications and identify all the pages, all the inputs in order to validate those. So how do you tackle that challenge? And I'm going to talk about how we've done that. And then the infrastructure. So what's the security posture of your underlying infrastructure? Jason talked a lot about infrastructure as code. Everything that we do is infrastructure as code. Every server we build, every web application firewall, every network, everything we do is infrastructure as code built in Amazon Web Services. So it's just as important that our infrastructure code is as secure as our application code. right? So we don't treat servers as pets. They talk about patching. We don't patch servers. We destroy servers and we create new servers, okay? Our developers don't access production. Well, okay, we shouldn't say ever. If they do, though, they have to build a jump server and SSH into that server in order to get access to any of the servers in the environment. By default, no one can get inside the environments. That's why they have log files. That's why we have log aggregation. We have application performance management tool. We pull all of that data out into a safe place so that our developers and our operations folks can access that without bouncing from server to server to server. So this is what our DevOps tool chain, this is going to be lots of tools flying at you. But I think it's important to understand what some of these tools are, what they do, and how security can fit into the use. So first, I want to state this is our environment. Every environment's different. This is a single case study, but the types of tooling are going to be very similar, right? Starting from coding, whether it's Eclipse IDE or Visual Studio or IntelliJ. We see all those, primarily Eclipse. We use Bitbucket, which is Atlassian's Git repository. Okay. So at the build test phase, really important one is Artifactory. This is how we make sure that all of our binaries are consistent. So when we want to install Java, we don't go out and get it off the internet. We get it out of our binary repository. We control the source of every binary we install. We don't get it from public repositories. We build our own repositories in Artifactory for updating Linux because we don't trust public repositories. The provision deploy, this is where you really get into some of the fancy tooling. Terraform is what we use to build our infrastructure. We use that within Amazon Web Services to build servers, to build networks, to build firewalls, to build managed database instances. We build everything using a tool called Terraform, and then we lay our applications down on top using Ansible. So I think you heard in the earlier presentation that, that Jason did talking about Chef, you've heard Puppet, maybe Salt. Different types of technologies. We chose Ansible because it doesn't require an agent. It's agentless. It uses secure shell or PowerShell remoting to access the servers in order to run commands. And then we use Packer for doing things like building AMIs within Amazon Web Services. Or if we want to build a developer desktop, we can use the same tool to build a Vagrant box that runs on your desktop. So you have the same environment from the desktop through all of your environments all the way to production. You use the exact same tools, the exact same code to build the exact same environments. No more developer, works fine in my environment. No, it's the exact same environment. So we've eliminated that problem through the use of consistent tooling. Then in test, we use tools like Selenium, Rest Assured, in order to conduct our functional testing. And I'll talk a little bit about how we've also integrated that into our application security testing. And then in the staging environment, so we talked about infrastructure as code. ServerSpec is a Ruby-based tool for testing your infrastructure. Do I have Telnet disabled? Yes. Do I have the latest patches? Do I have things configured the way I want? Use ServerSpec to test that infrastructure code the same that you would Selenium to test your application, right? And then we use Sumo Logic. We use a variety of tools to gather data in production, but primarily Sumo Logic for log aggregation and App Dynamics for application performance monitoring. So this is our core DevOps pipeline. And so we have a onboarding process where we bring teams on board. It varies depending on, we talked about the fact that we're a 40-year-old company, okay? So we've got some code that's been around a while, and bringing those teams on was a lot different than it is for a greenfield project. But we have a core team who manages the tools, the frameworks. We provide the training. We provide the assistance to all the teams as they implement DevOps within their organization. So now we layer on security. How do we integrate security into our DevOps pipeline? We talked about some of the different types of testing, whether it's static testing, whether it's doing dynamic testing on the running applications or infrastructure testing. We've laid all that into our pipeline, and I'll go through a couple of specific examples of the evolution of our DAST automation, for example, and how we implemented static security testing specifically. But looking again from the left to the right, starting with the first line of code, as soon as it's checked into our Bitbucket repository, we have check marks there to examine the source code for vulnerabilities. Before it even gets to Bitbucket into our Git repo, we have pre-commit hooks, making sure that developers aren't checking in secrets in their source code, right? We don't want secret keys and secret access keys for Amazon in our source code. So we check for that before code ever gets into the repo. So moving to the build and test, that's where check marks is mandatory. There's no way around this. Every application goes through a static analysis. We've got an onboarding process for those projects that have existed for a while and are introducing static analysis for the first time. We do it out of band. We do an analysis of their source code. We work with the teams to baseline their code, and then we very easily we just turn it on in the pipeline. It's as simple as configuring a Jenkins job. Okay? And at the heart of all this, right, from build through staging and even production, is Jenkins. It's really the orchestration engine for everything we do. So we also see the OWASP dependency check there. This is a big one for us. Third-party and open source risk is huge. I've talked to some penetration testers who, and again, I've heard folks talking about it in the last couple of days. First thing they do in a penetration test is start looking for vulnerable third-party libraries in an application, because you find a cross-site scripting vulnerability in Angular, well, that's going to be pretty easy to exploit. You've got your way in. It doesn't matter how secure your source code is. If you're using insecure libraries and third-party components, you are just as exposed, okay? So we use dependency check for most languages. We also use some other products. We've got some Node.js. Dependency check doesn't work well with Node. And Ruby, again, lots of false positives. So we use some alternative tools like Node Security Project and Bundler Audit on those projects. But every project has the ability to do dependency checking. In the provision and deploy, so we're using Docker quite a bit as we implement more microservices-based architecture. We've got a lot of SaaS products now. And a lot of them are being built on Docker. So how do you ensure that those containers are secure? So we use tools like Flaw Check to ensure the containers themselves are secure. On the server side, we use the Amazon Inspector. So this is an agent-based. We talked about the fact that everything is built as code. It's ephemeral. Ephemeral servers, ephemeral networks. The traditional Nessus scan, where you report here's a bunch of IPs to go scan, that doesn't work for us because those IPs may be there today, they may not be there tomorrow. It's constantly changing because we build servers, we destroy servers. They're not pets. We don't patch. They don't live long. Right? They live just long enough to fulfill their usefulness, and then we destroy them. So it was important that we have an agent-based solution for that infrastructure checking. And so we use Amazon Inspector. It worked really well for us because we're all in on Amazon at this point, but your mileage may vary. And then On the dynamic side, we use a couple of different dynamic tools. We use Arachne. Has anybody ever heard of that? A lot of people haven't. Okay, good. A lot of people haven't heard of Arachne. It's a great little tool. And then OWASP Zap. How many people have heard of that? Yeah, that's a much more popular tool. So we've integrated both of those into our pipeline and are used in different ways. So many of the teams run Arachne scans every single night and may use something like Zap and do a more intensive scan once per release. So we're not to the point of Amazon. We don't do 51 million deployments a year. Enterprise software, most customers just, they're not going to stand for that, right? It's a lot different when you're in an ERP system and the interface just automatically changes on you. That becomes scary and equates to lots of help desk calls. So, we do lots of smaller incremental releases, but spread out over time. Right? And then also in production, we maintain that Amazon inspector. So if for some reason a server lives for a month or 2 months, that's okay. We can still run those scans from the agent. Okay. So we've got all these tools. As you can imagine, it generates a lot of data. So what do you do with that data? Right. And so this is where we have implemented ThreadFix. All these tools feed their data into one repository. So I can at any time get a view into the security posture of any one of my applications. The data is fed as soon as the scans and tests are complete. And it doesn't matter what tool it is, checkmarks, dependency check, Arachne, Zap, they all feed into ThreadFix. When they don't feed into ThreadFix, such as Node Security Project, we write importers for it. It's a requirement. That data has to feed into ThreadFix. So we're in the process of writing that importer for ThreadFix right now. And this is our single pane of glass. I don't have Samuel L. Jackson here to shoot me with the buzzwords, but ThreadFix is our single pane of glass, and that provides us, my small application security team, with visibility into the entire portfolio of products. And it also gives us access to reporting and metrics. We can run some minor or some fairly simple reports out of ThreadFix. We're in the process of connecting the backend database into Tableau so that we can build executive dashboards. Executives love dashboards, right? So we'll be able to build the pretty whiz-bang dashboards and provide the view into the data that everyone in the organization needs, whether it's the executives at a board meeting or it's product management who needs to understand their portfolio of products. We can provide the level of visibility that they need through the use of a single tool. So I want to talk a little bit about the evolution of our DAST. I mentioned when we first started, we failed miserably. So this was pretty simple. We used HP Web Inspect. We would get scan requests in at the end of a release cycle. We would run application security scans. We did a very thorough job, but it was time consuming. We thought, great, we just plug this into the Jenkins pipeline and we'll continue using HP Web Inspect, no sweat. I don't have to have guys running Web Inspect scans anymore. This is great. It didn't work. So we had a 2-node, 3-node license, I don't remember what it was, but every morning I'd come in to messages in Slack. Hey, HP Web Inspect fell over. Jobs are stopped. We can't run builds. Right? Web Inspect, we don't have any HP people in here? No? All right. It didn't work. It just flat would not work in this situation. And the reason for that was, one, it wasn't built for it. And two, we had static servers. We had dedicated servers that ran Web Inspect. There was nothing ephemeral about it. They just queued up. I had 2 servers that can run 2 scans each. So I could run a total of 4 concurrent scans. I have 73 Scrum teams. It didn't scale. And so the queue would back up, builds would break because they're waiting on web inspect, and I would come in the morning to a lot of grief. So this was a complete and utter failure. So we decided we need to embrace DevOps ourselves. So we went out and looked at DAST tools. What tool is going to fit into our pipeline and still meet our requirements? The first one we started with was Arachne. Very easy to run from the command line, so we're able to plug it into Jenkins, run a simple command line, and kick off scans. Now, one of the things we ran into with web inspect, right, we talked about 2 servers, 2 queues. I didn't want that. If we had 1,000 scan requests, I wanted to be able to run 1,000 Arachne scanners. And that's where we are now. So we used our DevOps tooling to create AMIs and Amazon Web Services with Arachne. And so when Jenkins wants to run a scan, the first thing it does is it spins up a new Linux server running Arachne. It passes the job information to that slave, and it runs the scan. Again, it doesn't matter how many scan requests come in. If it's 1,000 of them at a time, I can scale 1,000 servers because we're running in the cloud. There's never a queue for dynamic scans. It doesn't exist today, right? And so this was great. We've got our dynamic scans. We've eliminated the backlog at the queue, the bottleneck. There's no more bottleneck. We can now run as many scans as we want. That's great, but how do we make sure that those scans are going as wide and deep as we need? So this is where we implemented our next iteration. We included login scripts. So we worked with the development teams, and we had to support a number of different login methods, but we worked with all the teams to develop login scripts. So now the scanner's logging in to the application under test, and it's using its internal crawler to crawl through the application. So we're increasing our coverage substantially. Now we're no longer looking at just public endpoints, public URLs. We're actually logging into the application. So we're able to crawl more of the application and get better coverage of the application. So again, this is incremental change. But we knew even then we weren't getting to all the application. We were getting to a lot of it, but we weren't getting everywhere. Our single page applications especially were very difficult to crawl. So how do we tackle that? So this is where we bring in, we add something else into the pipeline. So we used a product called HTCap, another open source project, okay? It is specifically a single page application crawler, and it works great with Arachne. And so now we use our login script, and then we feed that session over to the HTCap crawler. HTCap now crawls our application. And now it provides a vector file back to Arachne, so we're further expanding the breadth and depth of our scanning. And this was great. We were really happy with this. And one of the QA people said, yeah, but how do you get to these pages where you have to enter data to expose them? All right, how do we get to those? Now we integrate Selenium into our DAST pipeline. So we take the existing Selenium suite of tests that they're using for all their functional testing, right? They're testing every page in the application, every field. So what we've done now is we proxy that through our DAST scanner. And the DAST scanner monitors all the communication between the Selenium tests and the application under test. So now it's got a full view of every page within the application, and it understands context. Now it knows how to get to those pages, knows the right data to enter to get to the pages. And so now we have the maximum breadth and depth of coverage within our dynamic scans. So this was huge for us. And again, everything is built using the idea of ephemeralness, right? The Selenium slaves, they're ephemeral. So there may be 10 of them running at a time in order to get through a test suite. There may be 100 of them. It doesn't matter because everything is ephemeral, right? If we need multiple DAST scanners in order to handle the traffic from all the Selenium tests, we can do that. We can break our Selenium suite apart into different subsuites and feed those through separate scanners in order to achieve the full breadth and depth of scan that we need. All right, so I'm gonna pause here. Any questions before I move on? All right, so this was the evolution of our dynamic scanning. Our static scanning was a little different. We built that, we selected that from the ground up for use in our pipeline. So we went through a thorough evaluation of vendors. This is where we had to go commercial. We support too many languages: Ruby, .NET, Java, Go, Node, Apex. We support a lot of different languages internally. There are no good open source static tools. I'll tell you that now. You may find one for a language, for Java. There's some decent open source tooling for Java, but that didn't work for us. So we did a evaluation of the commercial vendors, and we were looking specifically for a vendor that gets DevOps, right? So many of the commercial tools that we've evaluated, whether DAST or static, they've got great UIs. You know, they've got beautiful portals and beautiful dashboards. And I told all the vendors, I don't want to ever see your UI. I want your tool to run invisibly, and I want you to put data into ThreadFix. I don't ever want to see your tool. If I have to see your tool, that means something's wrong. So Checkmark's got this, right? They understood. And so when we did the evaluation, we implemented this in Jenkins in our DevOps pipeline before we ever purchased, okay? And so we've worked closely with the vendor, you know, during the evaluation and post-purchase in order to develop the features that we need to run this in our pipeline. So if you are evaluating commercial tools, make sure that they're going to work with you and that their tool is going to fit into your environment. Because like we saw with Web Inspect, you know, not every tool is going to fit into your environment. And so with this, we've got a very consistent onboarding process. We run one single out-of-band scan. We suppress any false positives. We work with the teams. We identify legitimate vulnerabilities. We get those into their backlog. Once everybody's happy with the baseline, we agree this is the current status of the application. It goes into the pipeline, and that's it. No one sees the Checkmarks UI again. Right? So, talk a little bit about some lessons learned, because like I said, we failed, we learned a lot, and I want to share these lessons with you. So the first one, and this is absolutely critical. We talked about, for us, DevOps is a cultural aspiration. So as an organization, we wanted to build a culture where everyone was working together towards a common goal, no more silos, okay? But as individuals, a growth mindset is absolutely critical. And I did a lot of reading as we undertook this journey into DevOps and DevSecOps. Anybody heard of Carol Dweck? She's done a lot of research on growth mindset. I encourage you to go read her book, Mindset. It's a great book. And the key takeaways for me, your individual team members, they have to believe that they can grow their talent, right? They can grow their skills by applying themselves. No more, you can't have folks say, well, this is how we've always done it, this is how we should do it. No. Folks have to be open to growing their skills, and they have to be confident that they can do it, right? You have to view failure as an opportunity. I talked about the fact we failed miserably with our first attempt at implementing DAST in our pipeline. We learned a ton of lessons from that. We came back and we revised our plan, and we implemented something that's now wildly successful within our organization. You got to be self-aware. you need to know what your strengths are and what your weaknesses are, especially in application security. It can be hard to transition, from InfoSec to AppSec. They're different things. Security network's a lot different than securing the code in your application, right? You've got to be mindful of the strengths and weaknesses of your team. Do you have that application-specific knowledge that you need? If not, do you have a growth mindset? Can you go learn what you need to do in order to be successful? We had folks that, when we started the DevOps journey, they just didn't want to grow. And that's okay. And maybe they moved on to other positions in the company, to other organizations. But mindset for us was key. Culture and mindset were absolutely key. You got to get your hands dirty. Too often, security is seen as a blocker, right? We're there as the gatekeepers. No, you may not proceed. It won't work with DevSecOps. You've got to be willing to roll your sleeves up and get in there and help your development teams collaborate with them. Great example of this. We implemented a new cryptographic standard for SSL, right? We rolled it out to the teams. The teams used Terraform to build their load balancers in Amazon Web Services. They said, we cannot implement this. Why not? Terraform doesn't allow us to create custom SSL policies on an Amazon load balancer. We can select their pre-built policies, but none of those policies meet your requirements. What are we supposed to do? So we'll get back to you. And so we went back and we looked at Terraform. What does Terraform do? It implements an interface on top of Amazon's APIs. Is there an Amazon API in order to build a custom SSL policy? Yes. Okay. Can we build a plugin to do that for them? Yes, we can. So our team built the plugin for Terraform that would allow them to implement our policy in their code. You have to be willing to do that. If you want to win the hearts and minds of your development teams, that's how you do it. You roll up your sleeves, you get your hands dirty, you get in there with them, right? Lean in, you collaborate. We're, no longer gatekeepers there to say no. Now, everything is your job, right? You implement the agile principles. Everything is everybody's job on an agile team. It's the same thing here. Don't let perfect be the enemy of good. I can't stress this enough. Embrace agile, iterative development. Determine your goals. What's your minimal viable product, your minimal viable solution? Determine that up front, or else it's just going to be, no, one more feature. Then we'll let the development teams have it. No. Iterate, get it out there, get feedback, fail, but fail fast. Okay? And we've got a huge backlog of things that we want to do on top of what you've seen here. And we've got years worth of work left in front of us. We want to build WAF rules from ThreadFix. ThreadFix will give us a great mod security rule set that we could feed into an Apache web server and create a WAF. That's awesome. We don't use Apache, we use Amazon's load balancers and Amazon's WAF. How do I get those rules into that? So we're working on writing a translator from mod security into the JSON format that Amazon uses in their WAFs. I told you about the NSP importer for ThreadFix. We've dashboarding in Tableau. We've got ideas for hundreds of pre-commit hooks that we want to build. So our backlog, just like any other product in our company, our backlog just continues to grow. We prioritize our backlog and we develop off of that backlog, just like any other development team. Do I even need to say it? So, like I said, we learned with WebInspect, not every tool is built for DevOps. They're not all going to work. When we looked at our SAST tools, we realized that about a quarter of the tools that we looked at might work. The others just flat wouldn't work. They didn't have command line interfaces. They didn't have APIs. There was no programmatic way to interface with their applications. Same thing here. You have to use the right tools. You may have a huge investment in a tool. right? Sorry, that may not work for you. And so you've got to make sure that when you're evaluating tools and you're evaluating vendors, you're looking for a cultural fit. Again, DevOps is culture. It's a cultural aspiration. And so you need to make sure that your partners have that same cultural vision that you do. So, invest for the future, okay? That's what DevOps is. It's an investment. Gains may be weeks, they may be months coming, but you measure progress through incremental improvement, okay? It's important that you have management buy-in. When we started down the path of DevOps, we had board-level buy-in, strategic investment from our board of directors in DevOps. They understood that as we made the transition from an on-premise ERP company to a SaaS provider, the old way of developing and delivering software would not work. If we wanted to become a SaaS provider, we had to change the way we did everything. And they made a strategic investment in that. And DevSecOps was part of that. You know, the other thing is bringing in talent or growing talent. You've got to make that decision. Do you bring in folks who know what you want to do? Do you train your people in order to get them to where you want to be? Do you use a mix of those two? It's up to you, but again, it's an investment for the future. And when you make that investment in your people and your tools, your returns are going to be more time for those human security experts to do what they're best at. Threat modeling, external penetration testing, looking at the business logic of the application, looking at the architecture, the design. Those are the things that right now software doesn't do. And so by implementing this automation, you're able to free that talent up in order to do the really important work. Governor McAuliffe mentioned there are 36,000 open cybersecurity jobs. Well, maybe we can reduce the need for some of those by automating the simple tasks and leaving our most precious resource, our people, to do the really hard things. Okay? So, in summary, right, it's people and culture, not tools and technologies. Security, we've got to be an enabler, right? No longer a gatekeeper, right? No longer saying no. You have to lean in. Don't be a barrier, right? And make security a feature. When you implement DevOps, security needs to be a feature of DevOps, just like anything else. So make sure that you're building security into your applications, you're building it into your pipelines, you're building it into your infrastructure. It shouldn't be an afterthought. It shouldn't be a bolt-on. It needs to be built in. All right, acknowledgements. I didn't build this, right? I'm a useless management type. So I've got a great team who built this. So shout out to those guys who did the real hard work. And of course, RoboCop is a trademark of the Orion Pictures Corporation. And all images are copyright their respective owners. That's it. Questions? Yes. Yes. Okay. Yes. So we use Terraform to build, starting with the VPC, right? We build the VPC, we build all of our subnets, we build our NACLs, we build our security groups, we build our servers, load balancers. If you could build it in Amazon, we do it through code. Yep. And Terraform does that. So Jenkins, yes, Jenkins is our orchestration tool. So Jenkins is running Terraform code in order to build that infrastructure in Amazon. Jenkins is the key to it all. Everything runs through Jenkins. No, there is no manual tweaking whatsoever. I can take a brand new region in Amazon Web Services where we have nothing at all, and I can use Terraform and automation to build a brand new environment without any human intervention whatsoever. Yes?
Question, how long did it take you to get from your starting point before you were doing automation?
When we started the DevOps initiative, that was 2 years ago. So we started with a small number of products, 6 products, and now we've expanded that into many dozens of products.
Yeah, that's one of my products, I guess.
Okay, so it's a great question. We have this debate internally. How many products do we actually have? We have 73 Scrum teams, and of that, roughly 50 are now working with our pipeline, and we continue to add to that. So we first started doing it with Arachne. You could do the exact same thing with Zap. Yeah, totally automated. Jenkins kicks off the Selenium tests. It builds the test runners. It kicks off the test. The job tells Selenium where to route the traffic through the proxy, and so it's all automated. Any other questions? All right, thank you all. I'll be here afterwards. Thanks.